In this video, I'd like to talk a little bit about Python's scope rules. Now, if you're coming from another programming language, you probably already know this, but in general, each identifier you define, whether it's a function name, a variable name, or possibly a class name, as we'll see in later lessons, has a scope associated with it that determines where in the program you are allowed to use that name. We're going to focus in this video on the local scope as well as the global scope. So the local scope has to do with identifiers that you define in the block of a function, and the global scope has to do with identifiers that are defined outside of any function, or as we will see later in a subsequent lesson, outside of any class. So global scope identifiers would be things like standalone functions that we've defined so far, variables that we've defined outside of functions so far, for example at the in prompt in an interactive IPython session, or just outside of any functions in any of our scripts so far. And classes typically will have global scope as well, though you could nest these items within one another, so that also can affect their scope. Any identifier with global scope is able to be used in the .py file where it's defined, or in an interactive session if you define it in the interactive session from the point of the snippet that defined it onwards within that session. And as you'll learn in later lessons, you also have the ability to import any Python source code file as a module and be able to access anything that's defined within that file's global scope, and we'll see that in subsequent lessons. So with that said, let me switch over to an Python interactive command prompt, and let's start talking about global variables. So if I go and write a statement like x gets the value 7, I've now created within this IPython session a global variable called x with the value 7. Now when I go and define a function, we'll call this one access global just for demonstration purposes here. When I define a function, if I access a variable that is not defined within the function itself, by default Python is going to go look in the global scope to see if that variable exists, and if so, will allow me to access it. So for example, I could define a print statement, x printed from global scope. And of course we don't really need to display this right now. I just want to have some string information associated with the value so that when we have our output we understand what we're reading here. So in this print statement I'm using the variable x, but I haven't defined x as a parameter and I haven't defined x locally. So what's going to happen here is the interpreter will go out to the global scope and it will grab the value 7 and it will output it as part of this print statement. So now if we go call access global, you can see that indeed it was able to get the value 7. Now one thing that's different about Python compared to other programming languages with respect to accessing a global variable like this is that in Python a function is not allowed to modify a global variable by default. Anytime you do that, it's going to create a new local variable. So let's demonstrate this with a function. We'll call this one try to modify global, because that's what we're going to do in the body of the function. And let's go and say, okay, we want to change the value of x from 7 to 3.5. So normally if we did this assignment as just a standalone snippet at global scope, if you will, then it would be modifying the variable x back in snippet 1. But by default in Python, functions cannot modify global variables. So with that said, let's go create a print statement, x printed from, and just to save me some time here, let's put the function name and quote, and we'll output the value of x. Now, at this point, x is actually being defined locally right here. So let's go and finish the definition, and let's call our try to modify global function, and it says x inside the function is 3.5, which we can see right in the previous statement, so that seems to make sense. But if we thought we were modifying this x back here, well, you can see that x still has the value 7. So x in this case, when we assign to a variable in the block that belongs to a function, that creates a new local variable in Python, and that's a really big difference between how Python works and how many of the other C-based languages work. Now, when you define a variable locally within a function, that's going to shadow the global variable. So as of right now, there is no way for me to access the x with the value 7 inside the body of this function. However, it is possible to write a function that can modify a global variable. You should at least be aware of this capability. So let's define another function. We'll call this one modify global. You basically have to announce to the interpreter that you want your function to use the global variable that already exists. And you do that with a global statement. So global x says, for the rest of the body of this function, I want to refer, when I use x, I want to refer to the global variable x that we defined back in snippet 1. So at this point, if I go and change x, let's make it a string this time, and let's print out, whoops, x printed from, and we'll include the function name here as part of this, and then we'll output x. Okay, that defines the function. Now let's call the function. So x printed from modify global is hello, which we expect because the assignment right before that says what x's value is, but we still can't tell from what we just did whether the global x was in fact modified. So let's evaluate x once again in a snippet by itself, and now we can see that the global variable x is indeed the string hello. Now, you may recall that when we were doing calculations of the sum of a bunch of numbers in earlier lessons, that I often defined a variable called total. One of the reasons that I was doing that was to avoid shadowing the built-in function sum by creating a variable named sum. So we've seen expressions like sum, 10, 20, 30, and that's going to calculate the sum of those three numbers with the built-in function sum. But if I go and I say, let's create a variable named sum, and let's assign to that 10 plus 5. Now, of course, I can display the value of that variable. Sum is 15. But now if I say, okay, let's go calculate the sum of the list of values containing 10 and 5. Remember, the sum function can receive a list object or any kind of sequence of numbers, and it will add up all those values. The problem is I just redefined sum to be a variable instead of the function that's predefined in Python. So for the duration of this IPython session, the variable sum is shadowing the function sum. So, whoops, I accidentally hit a backslash there, but when I do try to execute that, you can see that the int object is not callable. Sum is an integer because I added the integer 10 and the integer 5 and assigned that to the variable sum. So let me close out of this session for a second here and jump back into a fresh IPython session just so that you can see sum of 10 and 5 in a list format is indeed 15. And you may recall we introduced the type function to you way back, I believe it was in lesson 2 of these videos, and one of the things that we showed you is that An integer is an object that has a specific type associated with it. A floating point number has a type. A string has a type. Well, so do functions. Functions in Python are in fact objects. So if I say type with sum as an argument, which is the name of the function, it tells me that it's a built-in function or method. So even functions are considered to be objects in Python. Now there's one other thing I just want to mention about statements at global scope. We've looked at a couple of scripts in this lesson and preceding lessons, and in each of those lessons, any statements that we wrote at global scope within those scripts are getting loaded. When I say to run the script using the IPython interpreter, they're getting loaded into memory and executed immediately in sequence from top to bottom in the script file. Even the functions themselves are being executed, quote unquote, meaning they're getting defined, and then of course we can later call them to perform their tasks. But statements that are standalone in a script file are going to execute as a result of loading that Python script into the IPython interpreter. So in a later lesson, we'll take a look at how you can effectively protect the global statements so that they don't execute unless you want them to, and there's a way to do that using an if statement. So we'll take a look at that capability in a later lesson.